Today, we're tackling a topic that often sparks a lot of questions and sometimes even fear: the possibility of electric car batteries exploding. Are these events actually common, or are we looking at isolated cases blown out of proportion by the media? Why do some people question the safety of these batteries? By the end of this video, you'll have a clearer picture of what's really going on with electric vehicle safety and how to separate fact from speculation. It's true that, in recent years, there have been reports of fires and even explosions involving electric cars. These incidents tend to draw a lot of attention, since any accident involving a battery-powered vehicle has huge potential for media coverage. When they happen, the press usually goes all in on dramatic footage of cars in flames. However, it's important to weigh that visibility against the total number of electric cars on the road. Today, there are already millions of them in use around the world, and the number of fire or explosion incidents is proportionally very low. At the same time, we can see that smaller devices like phones and laptops also use lithium-ion batteries, which come with their own risks. Even so, they've become ubiquitous, and safety improvements are constantly being made. While the risk isn't zero, electric car manufacturers are heavily investing in research and development of new chemical compositions, cooling systems, and mechanical shielding. There are layers of safety measures that include sensors, monitoring algorithms, and physical barriers, all designed to keep an isolated issue from turning into something bigger. When a fire does happen, it's usually due to a combination of specific factors, such as abnormal wear, manufacturing defects, or serious accidents. Why do some people insist that electric car batteries aren't reliable? In many cases, it's tied to a lack of information or the fact that a single incident gets massive exposure. Anything involving fire or an explosion grabs attention in every possible way, turning into a headline-grabbing story. On top of that, economic and industrial interest can help spread alarmist narratives. After all, there are sectors that feel threatened by the rise of electric cars, like those connected to oil and gas. Unlike what we see in other areas, a battery incident immediately sparks public curiosity, with people often sharing videos and photos on social media. This creates the impression that these events are frequent. However, if we compare them to combustion vehicle accidents that lead to fires, we'll find that those can actually happen more often. They just don't make the same media splash. Speaking of comparisons, cars with internal combustion engines have been dealing with fire risks for decades. A full tank of flammable fuel can be dangerous under certain circumstances. There are plenty of examples of gasoline or diesel cars catching fire, but those cases have become so routine that they barely make the news, unless something really unusual happens. Electric cars, on the other hand, are still seen as new by a lot of people, which makes battery-related incidents seem more serious or rare than they actually are. In reality, stats from several institutions around the world show that the likelihood of an electric vehicle catching fire isn't higher than that of a gas-powered one. In some studies, the chance of fire in an EV is actually lower. One of the key factors that reinforces the safety of electric cars is the constant evolution of batteries. The first lithium-ion batteries used in vehicles had chemical compositions that were more prone to overheating under extreme conditions. Today, many automakers are opting for LFP, lithium iron phosphate batteries, which, although they offer slightly lower energy density, provide greater thermal stability. This reduces the risk of fire in case of mechanical damage or management failures. Another safety pillar is the BMS, Battery Management System, which is continuously being improved. It monitors parameters like temperature, voltage, and current, adjusting or cutting off the charge if it detects anything unusual. This system can even deactivate specific cells to prevent an issue from spreading. Additionally, the layout of the cells into modules, with physical barriers and cooling channels, helps isolate heat sources. Automakers run impact, vibration, extreme heat, and even puncture tests to simulate harsh scenarios. So before batteries reach consumers, they've already gone through a rigorous evaluation process. When people hear the word explosion, they often worry about charging the electric car. Some believe that leaving the vehicle plugged in for many hours could raise the risk of fire. In reality, if the owner follows the proper installation guidelines, using certified chargers and a suitable electrical system, the chances of an issue are minimal. Failures usually happen in makeshift setups, with sketchy adapters or damaged wiring. That's why, when buying an electric car, it's worth checking the electrical setup where the vehicle will be charged. Good grounding, quality breakers, and GFCI protection devices are essential to ensure safety and avoid overloads. Overall, these precautions aren't very different from those needed when installing any high-power appliance, like a water heater, and the risks are about the same as with any poorly done electrical installation. Even with all these safety features, things can still go wrong. In most cases, investigations reveal specific causes, such as cracks in the battery pack caused by severe collisions, production flaws, or even botched mechanical work. These incidents are thoroughly studied, and manufacturers usually revise their processes to further reduce risks. To better understand how these situations unfold, it's worth mentioning a few high-profile examples that made headlines in recent years. One widely reported case involved a Tesla vehicle in 2018 in the US, which caught fire after a high-speed crash. Despite the dramatic visuals of the flames, later investigations showed that the fire started due to severe damage to the battery structure, something consistent with the intensity of the accident. There were also reports of a Tesla catching fire while parked in a garage, but again, forensic analysis found signs of a prior mechanical issue in the battery modules, possibly linked to undetected earlier damage. Another well-known case involved the Chevrolet Bolt from GM, which went through a recall due to fire risks in the battery. The company identified a manufacturing defect in some cells produced by a specific supplier that could lead to an internal short circuit. As a precaution, the automaker called for inspections on thousands of units and offered to replace the component to prevent any incidents. While these recalls sometimes fuel the perception of insecurity, they also show how seriously manufacturers take these issues, acting to fix problems before they escalate. It's not just passenger cars that have been in the spotlight. In 2019, an electric bus in a European city also caught fire after a failure in the battery cooling system. Local authorities investigated the incident and discovered that the maintenance company hadn't strictly followed the manufacturer's recommended protocol for checking the battery module. Once the issue was identified, the rest of the fleet underwent a full inspection and no further incidents occurred. There have also been reports involving older vehicles or prototypes. In some conversion models, cars originally powered by combustion engines that were adapted for electric propulsion, there are added risks if the battery installation isn't done to proper standards. Poorly made electrical connections, lack of management systems, and missing impact protection can all increase the risk of overheating. These examples show that most problems arise from very specific factors like manufacturing defects, physical damage, or improper handling. What stands out is that, despite all the media attention these incidents get, the number of confirmed cases is small compared to the total number of electric vehicles on the road. And every time something like this happens, manufacturers investigate the root causes to improve their safety system. So if a batch of batteries shows defects, it triggers a recall, replacement, and detailed inspection of every potentially affected unit. In this way, we can see that these events, while alarming, are far from being a routine part of EV ownership, serving more as opportunities for continuous improvement than as proof of widespread safety issues. Oftentimes, a single incident leads to improvements in battery cells, pack design, or management software, boosting the safety of the next generation of vehicles. This means that with each passing year, electric cars become more robust, learning from real-world cases and implementing solutions to prevent similar problems from happening again. The growing popularity of electric vehicles represents a major disruption across various economic sectors. It's only natural that some will push back against this shift, trying to discredit the technology. In some cases, disinformation campaigns emerge, using isolated incidents as evidence of supposed widespread danger. While it's hard to pin the blame on any one group, it's clear that fossil fuel industries or automakers who haven't yet invested in EVs might help spread these kinds of rumors. That doesn't mean all accident reports are fake, but some are taken out of context or presented without solid statistical backing to support the more dramatic claims. Before jumping to extreme conclusions, it's essential to verify the source of the information and weigh it against the sheer number of electric cars on the road worldwide. Beyond the technical data, it's also worth considering the perspective of people who actually drive electric vehicles. Most owners highlight the convenience of charging at home, the quiet ride, and the simplified maintenance, since electric powertrains have fewer moving parts. Many also appreciate the fact that EVs reduce local emissions. It's true that the upfront cost of an electric car can be higher, but in many countries, there are already tax incentives and perks to encourage adoption. On top of that, the ongoing development of a broader charging network is expected to make owning an EV even more convenient in the near future. When it comes to fire risk, few owners live in constant worry. Generally speaking, they trust the safety of their vehicle, especially since automakers offer extended warranties on the batteries, often up to 8 or 10 years. That level of confidence shows just how much the industry has evolved and how strongly it stands behind its solution. As the EV market grows, research into new battery technologies is moving fast. Solid-state batteries are seen as the next big leap, promising higher energy density, lower weight, and even less fire risk. While there are still challenges around mass production and high costs, many companies and research centers are getting close to overcoming those hurdles. Beyond safety, the industry is also working to boost energy efficiency and sustainability in battery production. There are already advanced recycling projects and efforts to reduce the use of rare metals. Over time, these improvements should make electric cars not only more reliable, but also more affordable and eco-friendly, making this form of transportation an increasingly practical choice. As we've seen, there have been cases of electric car battery explosions, but they're the exception, not the rule. The idea that an EV might just spontaneously catch fire doesn't hold up when you look at the facts. In general, when a fire does occur, there are clear contributing factors, such as structural damage or manufacturing defects. And let's not forget, gas-powered cars also face fire risks, but we're so used to them that it barely raises an eyebrow. With every new generation of batteries, tech advancements bring major improvements in safety, energy density, and reliability. Automakers are investing heavily to make their products more competitive and safer, meeting the needs of consumers looking for clean and efficient transportation options. That's why it's so important to filter out sensationalist noise and focus on solid, data-driven information. If you're thinking about getting an electric car or just curious about the topic, seek out trusted sources and talk to people who already drive one. The myth of random explosions is slowly being replaced by facts. Electric vehicles are becoming a solid long-term option, not just for environmental reasons, but also for safety, convenience, and cutting-edge tech.